In this question, we have two vehicles starting out traveling side by side along a straight road. We have their position functions, which are shown in the graph. S equals f of t is one of the vehicles, and s equals g of t is the other, where s is measured in feet and t is measured in seconds. All right, different parts to this question that we want to answer. Part A is which vehicle has traveled farther at t equals 2 seconds. Now, first off, this is the t-axis, so let's just correct that for them. And t equals 2 would be right here. So when t is equal to 2, the function g of t is at this particular position, which would be a y value of approximately 1. And when t is 2, f is at 2. So they said this is measured in feet, so 2 feet is further than 1 foot. These vehicles aren't obviously moving very quickly, but regardless, the point is that f of t has moved further at that particular point. Okay, now the next position, let me just get rid of all of this stuff here. All right, the next question says, to the nearest whole number, what is the approximate velocity of each vehicle at t equals 3 seconds? Well, the thing to know here is velocity is the first derivative of position. So these functions here are measuring position. So to get velocity, what we need is the slope at individual points. And the point in question here is where t is equal to 3. So where t is equal to 3 is right here. And this point is on the function f, and this point is on the function g. Now, the tangent line to a, maybe I should have used a different color than blue, but the tangent line to a line is just equal to the slope. So the slope of the tangent is just the slope of the line. And approximating the slope of this line, if I go from this point, which is on the line, to this point, looks like if I go up 1 and then over 1, then that gives me an approximate slope of 1 over 1, which is 1. Now for the other function, this tangent line looks a bit steeper, and we need to get an approximation as to just how steep that is. This is close to the 0.32, the way I've drawn it. We'll just approximate that. And then this point right here looks like it's at 2, 0. Okay? So if we go from this point to the other, looks like we need to go up 2 and then over 1. And then 2 over 1 gives us a slope of 2. So that gives me an approximation there. Which vehicle is traveling faster at t equals 4? Well, at t equals 4, the slope of the tangent line is of function g is larger than the slope of the tangent of f, so g of t is traveling faster there. And what's true about the positions of the vehicles at t equals 4 seconds? The two vehicles are at the same position, so their y value agrees. And if they're at the same position, that means that they're at the same place. So whichever answer is closest to that. So the vehicles are in the same place.